Good morning, students. Let us start to this bitwise operator in this lecture. And as the name suggests, first it converts the operands to the bits and then applies the operation on each and individual bits. Okay, means here the symbols are bitwise and. For bitwise and we applied single and symbol. For bitwise OR we applied single OR symbol. For bitwise XOR there is a power symbol like as mentioned in the PPTs. Then bitwise left symbol, then bitwise right shift, and then bitwise complement. Now for if we have to apply these bitwise operators on some example. Let's understand it by some example. Let I have taken 5 and 6. Okay, how the things will be implemented, how the result will be evaluated. First, there are two operands 5 and 6, and I have applied bitwise AND to this 5 between these 5 and 6. What will happen? Firstly, this 5 will be converted to the bit as given. The bits value, its binary value is called the bits value, will be 101, and before that in all memory places it will be filled at 0. The significant values are 101. Now the 6, similarly the 6 will be converted to the binary form, bits form. Bit form this will convert, means it will be converted to the 110. I hope you all understand, already know how the decimal value may be converted to the binary. For that 842, if the 4-digit values are sufficient for converting up to 15, 0 to 15 we require 4 bits only, and for 4-bit position is 8421, and depending upon the sum of the values we write 1 or 0, and this way we convert the decimal to the binary. And the binary value of 5 is 101, the 6 is 110. The first, these operands will be converted to the binary form 101 and 110. Then after that on each individual bits it will be applied, means last bit that is called LSB is 1 in the 5 and 6 in the 0. Bitwise AND operator will be applied on this 1 and 0, and 1 and 0 is 0. Logical AND I have already explained in the logical AND. If both the inputs are true, both the input are 1, the result will be 1. If both the input are false, the result will be false. If any of the input is false, the result will be false, means 0. This is the AND operation. And if I apply this AND operation to each individual bits, means I applied to 1 and 0, that is the LSB bit, least significant bit of 5 is 1 and of 6 is 0, and when we apply, I will apply this 1 and 0, the result will be 0. Now move to the next bit, that is 0 in the 5 and 1 in the 6. 0 and 1 will result 0. If any of the bit is 0, the AND operation will result 0. Now comes to the next bit, 1 in the 5, 1 in the 6, 1 and 1 will result as 1 because the both bits are 1. The result will be 1. Means we are seeing that the result of this bitwise operation is 110, and 110 is the binary of 4. Okay, so the result of this operation 5 and 6 will be 4, and we can check it by just printing this result, writing in the program, and put these operations to the printf function. Like I can write printf %d comma 5 and 6. Okay, in double quotes I will write printf bracket double quotes. In double quotes we have to write format specifier %d, then double quotes close, then comma, and then 5 and 6 bracket close semicolon. This way you can check whether the result are coming as same as we are seeing over here or not. Now The next bitwise operator is odd for the same operand 5 and 6, and if we want to apply this bitwise operator on 5 and 6, the same has to be done. First the 5 has to be converted to the bit form as 101, and then 6 has to be converted into bit form 110, and on each individual bits we have to apply this bitwise OR operator. And OR logic says that if any one of the input, if the any of the input is 1, the result is 1. Result is 0 only when if the all the inputs are 0. Means if 1 and 0, LSB in the 5 is 1, LSB in the 6 is 0, 1 or 0, results will be 1, because any of the bit is 1, the result is 1 in OR logic. 1 0 1 or 1 or 0 is 1. Okay, then come to the next bit. First one is 0, in 5 it is 0, and in 6 it is 1. The 0 or 1 will be 1. Okay, then come to the next bit. 1 in the 5, 1 in the 6, 1 or 1 will be result as 1. Means 1 1 1 is the result of this 5 or 6. Okay, 5 bitwise or 6. 1 1 1 is the binary equivalent to the 7, means the result of this will be 7. Okay, I hope you understand this bitwise operation. Now bitwise XOR. XOR logic says that if both the inputs are similar, the result will be 0. If both the inputs are different, the result will be 1. Following the same concept, I have evaluated 5 bitwise XOR 6. First the 5 will be converted same as to 101 in the bits form, 6 will be converted to 110 in the bits form, and from LSB bitwise operation will be started. 1 XOR 0 will be result as 1, because the different input for different inputs the result is 1, for similar it is 0. Means 1 and 0, 1 XOR 0 will be 1. Then comes to the next bit, 0 or 0 XOR 1, it will be 1, and then 1 XOR 1 will be 0. Means 0 1 1, and 0 1 1 is result equivalent to the 3. So the result will be 3. In the same way we can apply this bitwise XOR operator, as we understand. Now comes to the bitwise left shift. Bitwise left shift operator first converts the operands to the bits stored in the memory, and then shift each individual bits either left or right. The number of bit shift will be mentioned in the operation. Like if 5 left shift 1 means 5 will be converted to the bits, and each individual bits will be shifted by 1 bit to the left, like this. If the binary equivalent of 5 is 101, and the before of that will be filled as 0, and if we apply 1 bit shift, all the bits will be shifted to the left, and the last bit will be blank. 1 bit will be out of the scope, from means 0 will be out of scope in the left hand side, and 1 bit position will be blank, and there we will fill 0. Means 101 will be 1010 will be the result, and 1010 is equivalent to the 10. So 5 left shift 1 will results 10 in our example. Now if bitwise right shift, if I apply bitwise right shift 5, bitwise right shift 2, means I want to shift each individual bits 2 bit position to the right, and for that I have given here, this is here in previous example I have not applied that, but if you want to apply that, 101 will be shifted to the 2 bit position, then 01 will be go out of the scope, and previously 20 will be filled, and 001 will be the result, that is equivalence to the 1. Okay. Now come to this complement operator. What this complement operator does? If 6 is stored in the memory, that will be stored in the form of binary form, because it's a bitwise operations has to be performed. 110 will be stored, and when we complement it, it will be all the 0 will be converted to the 1 and all the 1 will be converted to the 0 first. When we see 1 at the MSB bit, the MSB bit shows, since and if the operands are of integer type, signed int type, the first bit will be of, if it is 1, means the rest of the value is negative symbol. If it is 0 at the sign bit position, the rest value is means positive number. For negative number, the first bit position, the value of the first bit position is 1 for the negative number, and it is 0 for the positive number. And when we complement the value of 6 bit, the bits of this 6, then 1 will become to the first position, and if 1 come to the first position, MSB position, signed position, then we understand that the rest of the value is the magnitude, and that will be the negative number. And to store the negative number, computer store the negative number in 2s complement form, and to convert the rest value to the 2s complement form, it first converted to the 1s complement. For a 1s complement, all the 1 is converted to the 0 and 0 is to 1, and then this means in 1s complement form 0 0 0 0 0 and last 1 1 0 will be the result. Okay. And then when we will add for 2s complement, we have to add plus 1 to the 1s complement, and that will result to the 1 1 1, means the result is 1 1 1 is 7 and first bit position is 1, means minus 7 will be the result. This way we can convert this, we can apply this bitwise operator. And the easy concept is that for if the result will be always will be minus n plus 1. If we apply complement operator, this tilde symbol, the result always will be minus n plus 1. If it is the value is 6, the result of complement operation will be minus 6 plus 1, means minus 7 always. If the value is minus 2, the result will be minus 2 plus 1. Okay, means it will be minus 1. It will be minus 2 means it will be plus 1, because minus 2 plus 1 means it will be plus 1. This way we can apply this bitwise complement operator. Now the conditional operator, this operator symbol as question mark column is called a conditional operator. It is also a ternary operator, and ternary, I have already told in the previous lecture that ternary operator is an operator. To apply them we required 3 operands, and here you can see that in the operator symbol question mark column there are 3 operand: expression 1, expression 2 and expression 3. At the position of expression 1 we write some condition, and if the condition is true, the expression, the value, the statement written to the place of expression 2 will be evaluated, otherwise the expression 3 will be evaluated. Means at expression 1 position in this conditional operator, we at the place of expression 1 position we write some condition, and if the condition is true, the value written to the place of expression 2 will be evaluated, otherwise if the condition of expression 1 is fail, then the value of expression 3 will be evaluated and executed. This way we can apply this conditional operator. Here I have used a example 12 greater than 6, 1 or 0. It also returns the specified value, and we can use that to, we can hold that to some variable in use in further processing. If 12 is greater than 1, if 12 is greater than 6, 1 will be returned or 0 will be returned. If this condition is false, means here the condition is true, that's why the true place value 1 will be returned, and we can accommodate that and process according to our requirement. Okay, now this expression I have already explained this. Then now comes to the size of operator. Size of operator gives the size in the byte, the memory size that required to the operator, operand, constant or some data type in bytes, and return it. We can hold that to some variable and we can directly print that or hold in some variable for further processing. If I write size of int, if the processor is of 64 bit, it will result 4 byte, means 4. Otherwise, if processor is of 32 bit, it will return 2, because the size of integer in 32 bit processor is 2 byte, and for 64 bit processor the size of integer is 4 byte. Now size of 5 is integer, the same thing will be there. Size of 5 plus 6, 5 plus 5 is integer, 6 is integer, and integer plus integer is always integer. That's why the size of 5 plus 6 will always be 2. Here I have considered the 32 bit processor example. Okay, if I have write size of any character, let's say single quote A, it will give 1, because the size of character is 1 byte. If I write size of float, it will give 4. Similarly, whatever the size supported by the language of C language will be maybe find by this size of operator. There is also a operator, that is comma operator, and comma operator is also a special operator, that if a variable, if I have assigned a number of values to some variable separated by comma, if the values are separated by comma, then in first example where I have written a equals to 3 comma 4 comma 5, the first value we assign to this variable a and rest will be ignored. But if I apply bracket to the value, if I written a equals to in bracket 3 comma 4 comma 5, then the last value will be assigned to this variable a. Similarly, the comma operator works. Okay, now comes to the this way we have completed the different operators. There are number of operators we have studied, like arithmetic operator, where plus, minus, multiply, divide operations are performed. Then we have covered relational operator, equal equals to check the equal relationship, greater than to check greater relationship, lesser than, greater than equals to, lesser than equals to, or not equals to. We have covered this relationship operator, relational operator, to check the relationship between the operands, that may be either true or false. Then we have studied the logical operator, logical AND, double AND symbol, logical OR, double OR symbol, and logical NOT, where the more complex logical relationship may be established by these operators. And then we studied unary operator, where we have studied increment or decrement operator, that may be either pre or post. And then we move towards the assignment operator, where equals to, plus equals to, minus equals to, divide equals to, multiply equals to, and modulus equal to are we understand that. And that we move to the bitwise operator, where bitwise AND, bitwise OR, bitwise NOT, bitwise left shift, bitwise right shift, and bitwise XOR are explained, where the operands are first converted to the bits, and then on each individual bits the operations are to be applied. And then in the last we studied this comma operator, where the comma separated values are assigned to the operands, and depending upon whether the values are in bracket or not, the first value or last value are assigned to the operators. Okay, now move to the next. This is the quiz that I preferably used to perform in the classrooms. Now comes to a point that operator precedence and associativity. What? The precedence and associativity. we have seen that there are number of operators provided by this C language. We have just studied that. And now what the operator precedence is? If there are more than one operator in a single expression, if there are more than one operators in a single expression, then the order of evaluation of the operators are decided by its precedence. The operators with higher precedence are evaluated before the operators with lower precedence. Means if there are more than one operators like A plus B into C, in expression A plus B into C, firstly multiplication will be evaluated, then the addition will be performed, because the precedence of multiplication is higher than the addition. This is the concept where there are more than one operators in a single expression, then the order of evaluation of the operators are decided by the precedence, and each and individual operators in C language have given a precedence order, that's a priority, and the operators with higher priority will be evaluated before the operators with lower priority, as I have explained through the example. Now what the associativity is? Here what the operator precedence is, that I have already told you. Then we will come to the associativity. What the operator as precedence means, in the example A plus B into C, multiplication will be evaluated, then the addition will be performed, because due to the precedence of multiplication is higher than the precedence of addition. Now what the associativity is? If in a single expression there are more than one operators whose precedence are same, if the same precedence operators are there in an expression, then the order of evaluation of the operators are decided by its associativity, that is either left to right or right to left. Here I have mentioned a chart that shows the precedence and associativity of each and individual operators provided by C. The operators whose precedence are written as 1 has the highest precedence, and the operators whose precedence are written as 15 has the lowest, means comma operator have the lowest precedence. And you can see that there are number of operators whose precedence are same, like here you can see that in this slide you can see that the precedence of less than equals to greater than equals to are same. Okay, similarly plus and minus precedence are same. Before that you can see that multiplication, division and modulus precedence are same. And when there are situations when the same precedence operator like A multiply by B divide by C, what will be done? Because the multiplication or division precedence are same, in that situation you have to take care about the associativity of the operator. Since the associativity of these operators are left to right, so we will move from left to right, and the operators that comes first will be evaluated first, and then when the operators will come after that, they will be evaluated after that. Means A multiply by B in A multiply by B divide by C, first multiplication will be done, then division will be done. But if we have written A divide by B multiply by C, here first division will be done, then multiplication will be done. Okay, means the order, if the same precedence order operators are there in a single expression, then the order of evaluation of the operators are decided by its precedence, that is either left to right or right to left. This way we have covered what the operators is, what the associativity is, and what the precedence of operator is. It's very important. There is a question always asked in the examination, explain different operators provided by C, explain with some operators precedence and associative. Differentiate operators precedent and associativity. I hope you understand it. Thank you. We will meet in the next video. Thank you. Thanks a lot.